work as a freelance developer of shoes. Just kidding. I'm actually a web developer, a freelance web developer, but I really did make these shoes. They're little baby shoes that I made. One of the companies that I work for is called fullstack.io. We write tons of tech books. We have a book about Angular. We have a couple of books about React. We have a Vue book. The latest book that we're hoping to publish in the next couple of months is called JavaScript Algorithms and Data Structures. If you would like a beta version of the book, you can come find me after my talk. Okay, so before I get started with like the technical side of my talk, I want to give a little bit of background. So for various political, social, and economic reasons, there are large numbers of orphanages in many regions in Africa. For example, in Uganda, there were 2,900 orphanages in 1992, and then in 2013, there's 50,000. So governments have begun to crack down on these orphanages because in a lot of cases, they're not actually helping these children, and in a lot of cases, there's abuse happening. So they shut down and suspended or banned international adoptions. And for the past couple of years, I have been working on a project for a nonprofit organization called Ikigai. They are working with orphanages and the government in Ghana to get these children out of these orphanages and back with their families. In a lot of cases, these children actually still have family members alive. Sometimes their parents are still alive. So they try to get them back with people that can take care of them or get them adopted. And the application that I built allows them to collect data and generate reports based on the data. So I actually inherited this project from a group of grad students at Santa Clara University. The first version of the application was built with PHP. Anybody do PHP out here? Which is great. PHP is great. But it needed a little bit of reworking to get it in a better shape. So I re-architected it to use Laravel, the Laravel framework, which was fine. It totally worked great. And but as the team started to use it more and more, it was getting pretty frustrating for them because their internet connection in Ghana is limited. So every page load required a round trip to the server, which when your internet is slow is not a great experience. So in addition to speeding up the application, Ikigai also wanted the ability to use the application offline. So when they went out to these orphanages where there was no internet, they wanted to be able to enter the data into the application directly rather than filling out a paper form and taking the paper form back to the office where there was an internet connection and there's a chance of data not getting transferred properly or missing data. So in re-architecting this a second time, I opted to leave the database structure alone because the database structure was fine. So I used RDS, MySQL database, and left that alone and focused on the back-end code and the front-end code. So for the back-end, I opted to use AWS Lambda, and I used Lambda for two reasons. One, I am not a DevOps expert, and Lambda makes it really, really easy to write server-side code without having to maintain a server. And since I was the only person working on this application, not using my headspace to maintain a server was really valuable. And then the other reason was switching from an EC2 instance that was running PHP to AWS Lambda significantly reduced the costs on AWS. So right now, Ikigai is essentially paying for the database because Lambda is so cheap. And then finally, I use React for the front end because I'm a React fangirl. And I also needed a single-page application. Like I mentioned earlier, making a round trip to the server every time a page needed to get loaded was getting frustrating, and so making a single page application was a really great way to reduce the amount of data and pages that were getting loaded, or the amount of times that I needed to make get stuff from the server. So what is a progressive web app? I'm sure a lot of you are familiar with this term, but I just want to run through a couple of like features of a progressive web app because it's relevant to what I built for Kaime. And this isn't a comprehensive list of features, but these are the ones that are relevant to the application that I built. So obviously it's progressive, but what does that really mean? It means it works for every user, regardless of browser choice, whether somebody's on a mobile phone that has a really slow connection or an awesome MacBook Pro. That it works on all different types of devices. It's responsive, which means it fits any form factor, desktop, mobile, tablet. It's connectivity independent, which means it's enhanced with service workers, which I'll get to in a minute, to work offline or on low quality networks. And then it's safe. So it's served via HTTPS to ensure content is served securely. So one of the first things you can do to improve your web application is to use a tool called Lighthouse. It's from Google, and if you're not familiar with this tool, it allows you to do an audit on your web application to see where you can improve in performance, accessibility, progressive web apps, all those features that I just talked about, and it can give you some great insight into where you can improve your application. So I tried to run Lighthouse on the PHP version of my application, and the audit didn't even finish running. It stalled out. I don't know if my PHP application was really just unprogressive or what, but or if maybe Lighthouse isn't meant to run on PHP apps. I'm not sure. It just didn't work. I don't know if you can see, but the text down there says, as page load time increases from 1 second to 7 seconds, the probability of a mobile site visitor bouncing increases 113%. So yeah, it just was not great. So I ran it again on the new version, and this is just a screenshot of all this information you can get from Lighthouse. It's a pretty extensive report, and it's just a great way to just get a gut check of how you can improve your application. Here's just another screenshot of performance, just some various things that you can do to improve your application. And then here's another, this section is specifically about progressive web app features that you can improve on. So service workers. So in order to make any application accessible offline, you have to make use of service workers. Service workers are JavaScript files that allow you to cache other resources, such as other JavaScript files, CSS, images. Then they can then be available offline. Service workers only run over HTTPS and make use of promises. So let's take a look at how the service worker works. So there are 3 stages in the lifecycle of a service worker: the registration phase, the installation phase, and the activation phase. To register a service worker, we'll need to add some code that looks like this. The outer block detects whether or not service workers are supported before trying to register it. Then the register function registers a service worker, which is just a JavaScript file in our application. And then we have a then and a catch to handle what happens when the promise is either resolved or rejected. So this is what our service worker file actually looks like. It handles the install event, which caches our assets. First, we add an event handler on the install event, and then we call the wait until method on the event. This holds the service worker in the installing phase until everything is ready, is good to go. Inside the wait until, the caches.open method is called, and then that creates a new cache called V1, which will be V1 of the site's resources. And that can be any name that you want. It doesn't have to be V1. So if your service worker has been previously installed and there's a new version of your worker available on refresh or page load, for example, you've updated your application, you have a new JavaScript files or new CSS, or it's been edited, the new version is installed, but it's not activated. So in this code, you'll notice that it's the same install code that I showed you in the previous slide, but we've renamed our cache, meaning we have new assets to install. So it's now called V2. So the new version of your service worker is only activated when there are no other pages loaded that are still using the old service worker. And as soon as there's no more pages loaded, then the new service worker gets activated. So if you're a React fan like me, Create React App does this all for free, so you don't have to write this stuff. When you create a new React application, there's an option to add service workers and cache assets offline. And this is an example of what your index.js file looks like in React. So if you switch the last line, service worker.unregister to service worker.register, that will allow you to make use of service workers. Another aspect of this project that was pretty critical, I don't know if this is obvious or not, but I needed to actually know when the user was online or offline. The navigator.online property returns the online status of the browser with true meaning online and false meaning offline. So in the application, I started to notice a lot of code that looked like this, a bunch of if-elses all over the place. And to make my code more maintainable, I created a function that took two callbacks as parameters, an online callback and an offline callback. So using this function, I could customize what happens when a user is offline versus online. So when the user's offline, how do we store data that's getting created and updated? There's a few options for storing data offline, but first I'm going to give like a few guidelines on storing data offline. Number one, like you have a limit of 50% of the total hard drive storage. Like for example, if you have a 500 gigabyte hard drive, 250 gigabytes total allowed for the browser. And then there's a limit of 10 megabytes to 2 gigabytes per group, where a group is an origin like google.com. Okay, so in researching the technologies I needed to use for this project, I found that there was a few different options out there for storing data offline. There are a lot out there, but these are the ones that I became familiar with for this project. One of them is PouchDB in conjunction with CouchDB. So PouchDB is a client-side library that syncs with CouchDB, which is a NoSQL database. PouchDB makes it easier to sync changes when going back online from an offline state. If you have a user who has edited data while they're online and a different user editing data offline, there are merge conflicts, PouchDB allows you to gracefully handle those issues. So the con in using this for my project was that I would have to migrate my MySQL database structure to a NoSQL format, which is something that I'm not super familiar with. And I had been burned in the past, biting off more than I could chew with refactors. And so I really, really wanted to leave the database alone, so I opted not to go down the route of using PouchDB with CouchDB. And on top of it, the application that the data was really meant to be a relational database. It didn't really fit the NoSQL format of things. Okay, so another option is IndexedDB, which is a low-level API for client-side storage of significant amounts of structured data, including files and blobs. And then this is from the MDN docs. IndexedDB API is powerful, but may seem too complicated for simple cases. If you'd prefer a simple API, try libraries such as all of that huge long list, and that make IndexedDB a little more programming friendly. So I read this and I was like, yeah, okay, I'm not gonna go down the path. And I looked through the docs and I was like, I'm the only developer on this project. This looks a little more complicated and I don't have 7, 8, 9, 10 months to work on this. So I opted not to, but I think if I went back and re-architect the application, I would go down this path of using IndexedDB because it fit better with the data that I was saving offline. But ultimately, I ended up using local storage. So local storage is a property on the window object, and the stored data is saved across browser sessions. It's a key value store that has a set item, get item, and remove items methods on it. So only strings can be stored in local storage. So if you want to store anything other than a string, you have to turn your data into a string. One caveat is that while storage limits for local storage are larger than something like using cookies, you can't store like gigabytes of data unless the user specifically allows for it for a domain. So typically the local storage limit's around 5 to 10 megabytes. So here's an example of how I use local storage in the Ikigai application. Since I was frequently using JSON objects, I used the JSON.stringify method to turn the JSON objects to strings. And then when I pulled the data out of local storage, I'd have to parse the strings again and turn them back into JSON objects. OK, so in order to properly save a child's record online and offline, I used my online offline function that I had showed you a couple slides back. And saved it via the API to the database or updated the key value in local storage. And then anytime the child's record is saved offline, I set a flag in the local storage record indicating the record had an optimistic update. You can see right there. OK, hopefully this demo goes OK. Go back. OK, so this is what the Ikigai application looks like. Let me get some test data here. So you can see right here this first record here. Actually, let me go back a little bit. So this black button right here allows me to download a particular record and save it offline. It might take a little bit of time. We'll see how long it takes. Hopefully the Wi-Fi works OK. Come on. Great. OK, so now it's gray. That means that that particular record is saved offline. Right now I'm online. So if I go in and edit, I can just change hello, hello. And then I'll save it. And then if I go back up here, and then if I go up here and then turn off Wi-Fi, you can see now that the only records that are showing up are the ones that I've downloaded to my application. And so then I'll go in here and edit this one again. Earthquakes. Are not great. OK. So then if I go back, so I have these two records here that are highlighted red, which means that there's been data that's been saved offline. So then if I go back online, hopefully I'll get connected again. And then we go back. If I go in here, it'll say this child has updates that were done offline. And so I have the option to upload the offline data, or I can opt to not upload that data if I wanted to. So yeah, let me just go back to here. OK, so yeah, that's how it works. OK, so in this process, there were quite a few challenges and frustrations that came with this project. Dealing with offline applications is not an easy task. At one point, the team in Ghana was having some issues with the application, And I couldn't reproduce the issue on my end. It always works on your own computer, right? So we had a Skype call with them, and they were literally holding a laptop up with the the application running with the computer that was offline, because you can't do a screen share with a computer that's offline. So I had them opening like Chrome DevTools and inspecting the elements and like looking at inside, trying to figure out what the problem was. So like the time difference, the language barrier, and the technical capabilities of the team made for some interesting challenges and required a lot of patience on both ends. And we're still working out some bugs, but in general, it's a much better experience. So this is the Kame team in Ghana. So in thinking about how to build this application, I knew that I could impose a few constraints on how the offline interactions work. The Kame team in Ghana is very small. There's just 4 people working on it to gather information about the children, so it was easier to manage how the users would be allowed to use the application. I knew that there would not be a risk of a user potentially editing a child's record online and then somebody else editing the record offline, because they all work together. Obviously, if the team scaled up in any way, I'd have to rethink my approach, and there would be different constraints. For example, as the number of users scaled up, maybe I'd have a child's record assigned to a particular user to ensure that the data would not get overwritten, or maybe I'd consider using PouchDB with CouchDB so that I could handle the conflicts there. And then finally, one last thing, I just wanted to share something that I have seen floating around the internet in a few places. It's this Japanese concept of Ikigai. I really hope I said that right. If you speak Japanese, please come up to me later and you can correct my pronunciation. So everyone, according to Japanese culture, has an Ikigai. Discovering one's Ikigai brings satisfaction and meaning to life. When you combine these 4 things, what you love doing, what the world needs, what you can get paid to do, and what you are good at, you can find your sense of purpose, your Ikigai. For me, this project has been an Ikigai experience. I've loved stretching my engineering skills and feeling like this project has provided more value to the world than some of the other projects that I've worked on. So I hope you can all find, there's the Ikigai. It's in the center of the circles there. I hope you can all find a way to use JavaScript in helpful and useful ways that go beyond the typical ways we think of creating web applications. I hope you can all find your Ikigai experience with JavaScript. And that's it. Thanks.